Hi, so today we will be discussing a dashboard which I created on Streamlit for my project. So in this dashboard, I have used US labor statistics data. And the key features that I have used in this dashboard is time series data analysis and interactive charts and filters for user engagement. These filters can be used for selecting the date and series by the users according to their interest, and the correlation analysis and trend analysis for forecasting. Next, we take a look at the data table. This is the overview of my data, and I have selected four series ID in this, and these series names are total non-farm workers, unemployment rate, unemployment level, and average weekly hours. And this is a clean data which was processed from the raw data. Next, we move on to our chart. So in the chart, I have a bar data, and this bar data gives us the unemployment rate over the period of time. And so I can see that the unemployment rate has been relatively stable over the period. It shows only some minor fluctuations from month to month. So it has been relatively stable over the past years. And the salary is ranged from 150 to 55K, which is relatively good. Next, we move on to the pie chart. So in the pie chart, it gives us the distribution of the labor force. Here we can see the majority of the labor force is occupied by the non-farm workers, and only small numbers are occupied by the unemployment level and unemployment rate. That gives us a picture of a healthy labor market with very high employment and low unemployment. So yes, that's a very good sign. Next, we move on to the histogram. So here we can see that the data is concentrated in the lower range, and there is two peaks in the upper range. So this means there are um, the non-farm workers, the distribution of non-farm workers is really not uniform, and it has heterogeneity in the data. So yes, so histogram distribution has total non-farm workers against, so it suggests that there is like some heterogeneity in the data. Next, we move on to scatter plot. In the scatter plot, I can see there is no clear correlation and there are no strong linear relationship among the two variables. I have plotted the unemployment rate against the total non-farm workers, and it shows there seems to be a cluster of points in 158,000 mark. So it shows that the cluster doesn't have a clear trend in the unemployment rate, and unemployment rate seems to vary between 3.4% to 4.3%. So there is no stronger correlation between the total non-farm farm workers and the unemployment rate. So this doesn't necessarily lead to predictable changes. Like this doesn't mean that the variables do not necessarily lead to predictable changes in the other. Next, we go to our third tab, which is a relationship analysis. So here, in the relationship analysis, the diagonal element has 1, 1, 1, which means they are highly correlated, and the positive and the negative correlation means they are not much correlated. They are negatively correlated. And so the two series IDs are not very related, and the positive numbers means highly correlated. So yeah, one is the closely correlated, and we can see that mm, that this ID and this ID is closely positively related. So yeah, and the other correlations are moderate, and CEC001 and LNS is also positively related. So this series and these correlations are very useful for making predictions about future values. So if there is a highly correlated series, we can remove those, and we can make our you can remove those for our prediction. Next, we have trend analysis. In trend analysis, I have used a line chart, and the line chart has slightly upward trends from January 2022 to January 2012 for total non-farm workers, and the line remains relatively stable throughout the period for average weekly hours. This is here there is a blue line underneath the red line which has average weekly hours, and these two, unemployment level and average weekly hours, are relatively same, so they are mostly stable. And unemployment rate is flat, suggesting that unemployment rate has been relatively low and stable over the period of time. Next, we move on to seasonal decomposition. So here the blue line represents the, so I have used total non-farm workers. I have used so this chart is very useful for forecasting total non-farm workers using Holt-Winters exponential smoothing method. So the blue line here represents the historical data for total non-farm workers, and it shows a clear upward trends over the period of time. And the red dashed line represents the forecasted values for the future. So it continues upward in the historical data, which shows that non-farm workers is expected to keep increasing in future. And the Holt-Winters method is used to smooth the data and account for both level and trend components, which helps in more accurate forecasts. So we can see that non-farm workers are increasing over the period of time, and the forecast shows that non-farm workers will keep increasing in future. Next, we move to seasonal trend analysis. In this, it shows upward trend. So there is a clear upward trend, which means there is seasonal fluctuation in non-farm employment. So seasonal fluctuation in non-farm employment are increasing over the period of time. Next, we have trend component, and this also shows upward trend from 2022 to 2023, and then it goes downward in mid 2023, and then again upward in mid 2000 after mid 2023. So this trend starts to increase again. So there are some fluctuations in the trend line. This indicates that there is underlying growth rate of non-farm employment. And the seasonal component of total non-farm workers is around 155,537. So this indicates that there are seasonal patterns in the data with variation around the average value, and the latest trend is of total for total non-farm workers is 232. So this means that the overall trend in non-farm employment is upward with a growth rate of 223.24. So so the struggle which I have faced in this project is that I had to deploy the dashboard using Streamlight on cloud platform for the first time, which was a bit tricky, and ensuring that my data was correctly loaded and the interactive elements are working seamlessly. The dashboard displayed across different devices took time to troubleshoot. It took a lot of time for me, so I guess that was the difficulty I faced. But and also implementing the whole winters for forecasting model, I faced little difficulty in choosing the right seasonal period and handling cases where there was insufficient data. What I would do differently is, okay, I have learned in this that how to process and how to load, process, and filter large data sets with the help of pandas in Python, and creating interactive visualizations in Streamlit, which was a very hands-on experience with tools. And this will be useful for me in future when I can apply and my forecasting like I can use my skills to make predictions about different datas. And I think the different thing I would be doing for this, that I would invest more time in cleaning the data so that data is fully pre-processed before visualization, and there is no null values for the outliers, because this would really save a lot of time and I would avoid issues later in the project. And also, I would focus on conducting more testing for the dashboard, specifically asking for feedback from my friends or different people to identify usability improvement in terms of like filter options and overall flow. Thank you.